for today. So guys, let's continue with the next part. Welcome back. And so let's see what the plan for today. So today, guys, I would like to start a new topic in AWS Cloud. Okay, that is called load balancers. Okay, or I can say the elastic load balancers. There's some small topic is there in the VPC that we'll discuss after in some classes, because after having load balance and some more topics, then that knowing that particular topic of VPC makes more sense, right? So right now, what I'm going to do, like I'm going to start a new topic in today's class, that is the load balancer, right? So first, let me explain you the use case, what challenges we are facing, or what challenge we might face if you don't have the load balancers, and then you automatically understand the power of the load balancer, right? So there's a multiple different challenges you guys can have if you don't have the load balancer. And guys, after this load balancer, even though we have multiple different type of load balancer, that's what we're going to discuss. Okay, classical load balancer, network load balancers, application load balancers, then gateway kind of load balancers we have. So multiple load balancers we have. We will discuss all the load balancers. Obviously not in today's class, but by till tomorrow, I think almost all the load balancers will complete. And one more topic that is more connected to load balancers called auto scaling group. Okay, after having this topic, understanding this topic of auto scaling group also been completed. Okay, so there is the further plan, guys, for this 2 or 3 classes from today onwards, right? So let's discuss one by one the use or the challenges or the use case where we need load balancers. Okay, so one case where we can use a load balancer is something like this. You guys know we have multiple AGs. So let's say one of the AG in Mumbai region is 1A. Okay, and we launch our resources, and let's say one of the resources called EC2 in this particular AG. Okay, and my client is connecting to this particular instance, obviously maybe from some network or maybe over the internet they connected. Okay, now it's all depend, guys, upon your requirement in the use case. Maybe this instance is running with some kind of web app, let's say website. Okay, and this website maybe your entire company business, e-commerce site, and your business is running on the top of your web app that is hosted in this instance. It means there's two challenges you will have here, because it is not the small thing, is the entire web app running and your business depend on this. So for us, it is a mission critical application, I can say, or I can say this is the application running in my production, and I don't want in any of the cases my applications goes down, because it is for us is a mission critical kind of application. Okay, it may be a banking application, it may be your e-commerce, running business, financial, or anyway, anything. Okay, so my point here is, if your applications are running in the instance in 1A data center, okay, then there's two big challenges you will face. One challenge may be, okay, due to any of the reason, if your entire data center goes down. Okay, Amazon is not giving you 100% guarantee. Maybe they're giving 99.9% guarantee, something like this. The data center don't goes down, but there's a possibility it might goes down. Okay, and in this case, Amazon is not taking any responsibility of having any downtime in this region, because they already have the SLA, they already have their service level agreement with you. They say 99% they are always up. But for us, that many hours or minute your instance goes down. Okay, and that many time or that much time your client won't have a connectivity, it means you will lose your reputation, because having your website goes down maybe on a working hour, it will highly impact the reputation of the company. Okay, like let's for example, Facebook goes down for some minute, it will impact the reputation. Okay, plus it will also, you also lose the business, because some lot of banking transaction is going on, customer purchasing your data, also your products, they can't do the business with you, so huge loss in the business. Okay, so it is up to us to properly plan the strategy. There's something disaster happen, okay, disaster happen, then how we can plan for DR, that's called disaster recovery. This plan we have to do. Okay, and one of the plan in this example may be, what can we do, we can launch one more instance of EC2 with the same web server running or website running in the other data center, let's say in 1B in Mumbai. And that is guys one of the reasons why Amazon has multiple AZs in one region, so that we can plan our disaster recovery properly. Anything happen, so if one AZ goes down, second AZ, they normally keep in very long distance, almost 100 miles and some kilometers. So due to maybe earthquake or some tsunami or some kind of natural calamities, if something goes down or failure, other data center won't be, or AG won't be affected. So this facility Amazon gives to you to have one more AG, but how you're going to leverage this facility, that will be up to you. So if you think your application is very important, so what can you do? You can have one more copy of the instance running here. Okay. So one challenge what I'm talking about, guys, is use case is, or challenge is disaster, or I can say use case is disaster recovery. It will impact these two things, or maybe any more things for you. Okay. So how we can solve this use case? Here we will use the load balancers. How and how they will solve in a minute, I will explain. Okay, so this is one place where we can have the use of load balancer we can use. Okay, one more challenge, guys, I will let me tell you first, then I'll explain what is the load balancer and how we're going to use this. Right, one other challenge may be your application is running in one data center here in EC2, and there's a new website you launch, a new product you launch as maybe startup company, and you start doing the marketing. And maybe your product goes viral. A lot of guys and a lot of customers start liking your product goes viral. So there's a possibility, okay, as per your plan, what are the plan you have planned for, that maybe you plan that till tomorrow I will have around 1,000 customer come, or maybe plan, let's say, in a second, the way we are doing a marketing in a marketing campaign, almost 10 clients per second gonna hit my website. Okay, according to plan, that you launch a website instance with the instance type that have this much RAM, this much CPU, this much network bandwidth, and this is the application products. You write some development code like multi-threading, tons of things you plan accordingly. Okay, that if around 10 clients hit to your site, they will have a proper response, goes to the client, so there will be no as such slowness in the application. Maybe you might have planned for 100 clients, that in a second, if till 100 clients come and hit my website, that is the maximum bottleneck we can handle. Okay, in terms of network bandwidth, RAM, and my application's internal code, application, whatever the developer write the code, and the way they write the code. But there's a possibility that you might have more than 100 clients hit to the server. Okay, so maybe suddenly, let's say in a second, your marketing campaign goes viral, and now what you start seeing, that now every second more than 10,000 clients or 1,000 clients hitting. But your server can handle not more than 100 requests. So what happened? Remaining 900 requests, guys, the remaining 99 clients will see your either website is slow or website is down. They're not getting the proper response. So it is again a big issue in the reputation and the business. And point is simple. If the client hit to your site for something, if they're not getting the response, mostly they won't come back because of this bad experience. And it's a huge waste of money and the client base for your future business also. It means if a lot of load is coming as a network traffic from the obviously from the customer or the client, how you going to manage? This is again one of the second challenge. So one is the disaster recovery, one is a load of the traffic. How are you going to plan and manage? That's what we have to do. Okay, even though in this use case only load balancer might not be enough, we have to use auto scaling group also. What are these? I might give some idea today, but this is an exclusive topic. We will discuss tomorrow, day after tomorrow, this topic. But based on this 2-pointer, now it makes sense to understand what is load balancers. Okay, so what is load balancers? So idea is very simple. Okay, if you think there's a possibility one of the computer goes down, so it is always good practice. At least you have 2 computers running together, or maybe more than 2 computers running together, or instance running together. Together means they're running same time. It is your choice how and where you want to place. That was a different point, but you can have more than 2 or 3 computers. Maybe why? Because wherever you put in the computers, the entire data center goes down. There's a possibility your instance also fail. Again, because this is managed by us, it's not managed by AWS. If the instance fail, AWS is not taking any responsibility for this. You have to, and we have to take care of this. So in any of the cases, you can have multiple EC2 instances running over here. So let me give all the instances IP address. Let's say this IP address is 1, IP2, IP3. It will use and launch multiple. How many depend upon your proactive plan by respective operations team. They can plan proactively by some different method. How many clients can hit, again based on the marketing plan, how much they are doing the marketing. This is a different whole different topic about the infrastructure planning, right, or the resource planning and something like this. That's not the important point to be discussed here. Topic is very important, but it's not the main point to be discussed here. But let's say I launch 3 instances over here. Okay, now what we will do, okay, now because you are running 3 instances with the same exact web applications here, exact same copy I'm running in all the 3 instances. Now what I can do, one of the facility I can do is I have a client somewhere, and I ask my client, right? I ask my client that is a one website is running, okay, and I am giving you all the 3 IP address, 1, IP2, IP3, all the IP address public. So do one thing, okay, do one thing, try with IP1. If you think IP1 is response, will give the response to you, that's nice. But but if you feel IP1 is down or they're not getting the response, then change your URL in your browser and type 2. If 2 is not responding, change your URL in the browser and type 3. So in this case, this problem can be solved. Which one? Disaster recovery, or maybe your instance goes down, can be solved. But for the user perspective, it's not a good user experience. Okay, if Facebook said I'm giving 100 different IP type, every IP one by one over Facebook1.com, Facebook2.com, none of the you can gonna do this. Right? They will type one name, one domain name. Okay, if they hit, they will use it. Otherwise, they will move to next. Okay, so this is not again the better solution. The better solution would be something like this. Rather than we give multiple IP to the client, okay, we can launch multiple instances having some IP address. So between client and the sorry, between the client and the instances, we can run one. We can put one computer or one system here, or one instance here. Okay. The beautiful thing about the instance is now this instance will have their own IP address, let's say IP100. And this IP address we can give to the client. Let's, can you hold for a second, please? So this IP address, guys, we can give to the client. Now, what happened? Now we have one instance and one IP if give to the client. So for the client side, it has a good user experience. That client has to only type one IP and one URL, I can say here. So this problem of user experience will be solved by having one single computer. But what this computer contain? Does this computer contain any web application? No. This computer doesn't contain any of your web application. Or what happened? What happened? Whenever client hit to this URL, client feel this is the website. They treat this IP100 as a website. This is what they type in the URL, http://IP100 or something like this. Okay, the path maybe. They feel this is the website. Okay, and when this client request come to IP100, the beauty of this system is, this computer is, or this device is, what they do, they will hold this request of the client behind the scene. Client have no idea, everything happened behind the scene. And this system, okay, this system on the client behalf, okay, on the client behalf, create a new request and send to one of the computers where actual web application is running with their own web pages and web data. Okay, so according to this system feel the request is coming from the client, but in this case, they feel the client is IP100. But doesn't matter, whoever sent the request to IP1, they will reply. So IP100 will request to this system, and this system will reply to IP100 only, or respond to IP100 only. And as soon as IP100 will get the request, this data, whatever the request they again send this data back to the client. So whatever the client request they hold in the same session or the same request, they send this data back to the client as a reply. So in this entire context, okay, the entire context, right? What client feel that they send the request to 100 and 100 is a reply. So they treat 100 as a final web server or web application server. But internally, we know we are the one who going to create this and set up this. We know this is not the web server. Okay, this system is only okay work as an intermediate in between between client and to the my final server as an intermediate between. And on the client behalf, they are sending request and getting the data from the real server. So in this context, this intermediate server is working as a proxy, typically known as a reverse proxy. Why proxy? Okay, because anybody who will do something on your behalf are known as proxy. So this computer is working as a proxy. It means actual request of client never hit to server. Never hit to server. So my real server won't see any request coming directly from the client. They only see a request is coming only from IP100. Okay. So what is the benefit of reverse proxy? After you have this setup ready, lots of powerful setup you can build on the top of this. One of the powerful setup you can build on the top of this. Now onward, you don't need to give any public IP to your instances. It means, sorry, you can run your instances in your private subnet. And private subnet will give you extra security, you guys know. So automatically you'll get an extra security for this. Now onward, you don't have to put your instances web server and where you want web server to be accessed by public world. Now web server will be accessed by public world without putting in the public subnet. Just by having private IP address, okay, we can access. Why? Because if client is coming from internet, that is a reason we need public IP. But now client is not directly hitting to your instances. So why we have to give public IP and why we have to put in the public world, we can put in the public subnet or private subnet, sorry, in the VPC. Okay. But because this proxy program, IP100, belongs to your company only. Okay. It's not a public one. So any computer running in your company means is running in your VPC. You guys know anything running in the VPC, they will have a private connectivity. So IP100 will have private connectivity to the IP, let's say, whatever, let's say their private IP, maybe let's say in this case is 101. They can connect to 101 very simply with the private. And you guys know when any private computer can connect any private computer, so sending and transition any data is very secure, very fast in the network perspective, and plus they're free. So any network traffic is going inside the VPC from one system to other system with one private computer to other private systems or computer devices, they won't charge you. So you will save the cost also. So after having this proxy setup in between, lots of benefit you will have. And one more benefit you will have here is now we can make this instance more secure by adding a security groups firewalls. Till now, guys, we are setting the firewall at anybody from anywhere in the world on port number 80 allowed. It's not a good rule in terms of security. Now, what can we do? We can create a security rule. Anybody who come from IP100 only, because every time now IP100 will come to you. Client will be anybody. Client can be any IP in the world. Client have billions of different IPs. But every client will come via proxy as IP100, and 100 IPs one always connect to this actual instances here. So your request will always come from IP100. So what can we write here? We can write here any computer come from any request come from IP100 on port number 80 is allowed. So the security group perspective, we have better security in firewall. We have no private public IP. So public IP will save. Plus my instance is not actually available to the public world. So it's called exposed. So we are not exposing any computers to the public world. That's also makes extra security layers. And 10 more further benefit of management you will achieve after having this kind of setup. But why we are creating this setup? Okay, we are creating this setup is not only for security. We can do the security in the other way also. We create this setup for one purpose. The purpose is now because my client is hitting only IP100, behind the scene, what is the IP address of my real instances where my real application running? These computers are known as backend servers. So what is my real backend server, which IP they are running? They are down or not? Client has no visibility. Okay, and where they're connecting, which instance they're connecting, client has no visibility. Client has to know only one single IP is called IP100. So it up to you, this system, let me use the word called D, up to the computer number D or system number D, they know where they're connecting. Okay, so in this case, what can we do? We can launch multiple backend servers. Okay, and we connect all the backend servers to your D computer. And here this D computer also known as front-end computer. Why front-end? Because this is the computer that is actually connected to the real client. So any computer that is connected to the internet client or the outside clients, they are normally known as front-end system. So D is the front-end system here. Okay, and all the real computers where my application is running, they are the backend. Okay, front-end guys have no application running only on the backend. Front-end is working as a proxy program for some extra security. I explained to you already. And one more thing, guys, front-end is working for you. Now, front-end guys here, because they know there's a multiple computer running behind the scene. So in this case, front-end is also work for you as a load balancer. Means when the first client come and send the request, okay, this front end has a capability. They see this first client come up. They send this first client request, let's say client number 1 to my let's say instance number 8. Second client come up, my front end will send this request to system number 2, let's say B. Third client come up from outside the world, my front end, or let's call load balancer, send the request to third client to the computer number C. So what is known as, this is known as load balancing. They are balancing the load. How? Let's say initially one computer can only connect 100 clients together in 1 second. Now we have 3 computers. So first request go here, second will go here, third go here, fourth will go here, fifth will go here, sixth will go here. So totality around, in this case, 300 connections we can do per second. Again, guys, 100, 200, 300 is giving a rough number. It may be more or less. But this many connections per second we can do. Means these many clients we can serve. You feel there is a possibility there will be more clients gonna come up, we can add more computers, one more computer, fourth, fifth, sixth. We can add more and more computer. And adding more and more computer to serve one thing, they're known as, this concept is called scaling. We are scaling the thing. We are scaling the computer, we are scaling the resources. And because we are adding individual computers, that is known as horizontal scaling. So here we are doing the horizontal scaling, and also known as scale out. So we are doing scale out here. Right now we are doing manually, but this scale out can be done automatically by taking the live decision with the help of auto scaling group. So that's what we'll discuss in the next classes. Okay, right now we will do it manually. So 3, 10, we do manually for this. Manually in this case, the scale out. So, so adding more and more resources is scale out. But if you think now in the future, or after maybe the next day, you feel that these many client doesn't come up, can remove the computer behind the scene. Okay, for example, we can remove 3. But if you remove 3, we have no issue in the client. Okay, because client is not directly connected. If they remove, client won't see it. Client don't have to update the IP address. Client will only connect to IP 100 only. We don't have to update the client, because asking the client to change the IP address is almost important. For example, Google said the IP change. How you guys come to know the IP change? Google said the name change google.com to google1.com. How you guys come to know? So we have to give one single IP, one single name to client. But behind the scene, any computer you run, create, remove, they have no visibility, because everything is running in the backend or behind the scene. In this case, if you remove, okay, your backend will know. So your front end will know, or load balancer will know it removed. So any next request come up of the client, they won't send here. They send to remaining computers. Okay, so either you remove manually, because you're not getting any connection from the clients to save your money, because if you launch more amount you have to give. Or maybe this instance maybe launched by somehow it failed. In any of the cases, your load balancer come to know that instance number C is failed, and because they know they have failed, so in the future any new requests come up, they won't send to this guy. Okay, so they will check that you will fail or not. Okay, and how they check? There's a concept called health checking. So my load balancer has a capability. Okay, any computer you connect behind the scene, this called backend, they keep on checking the health. Health means they keep on checking you. How? Because this D is a different computer, B is a different computer, and 2 computer, if you want to check the health means A want to check does B is connected. So in the networking world, the only way to check the health is keep on sending the packet. If they reply, means they are live. Keep on checking the packet. If they are running, if there's no other networking issue, no wire loose, there's no physical error, there's no firewall issues, they will reply. And if they reply, it means A will feel that B is running right now. We can use it. That is known as B is healthy. And checking this health is called health check. So that's a health check. So load balancer has a capability to keep on checking the health. And a health checking is a continuity thing. It is not like this. For example, right after I call your mobile number, and your mobile number is ringing right now, it doesn't mean you will have connected after 5 minutes. So I will check, does you are connected or not with me? It is a continuous process. I keep on checking, and by calling you after 1 second, 1 minute, 2 minutes, depend how frequently I have to check, are you healthy or not? you are connected or not. Okay, same thing in the load balancers. We can do this setting here. I'll show you how, that they can keep on checking they are healthy or not. If they're healthy, they will keep on using this for the next client request. If they feel they are not healthy, so they declare, load balancer declare they are not healthy, means they will say this is out of service, means their next client request they won't send to this. Okay, because if they send the request, they're not healthy, they're not connecting, so they won't reply. If they don't reply, how my load balancer will, or my proxy program will send back to the client. So these are the few capabilities of the load balancer. By default they will provide to you. Okay, so in this, by this example, what you achieve, okay, this part you achieve, if your huge traffic come up, load, we have more and more computer we can run behind the load balancers. Okay, plus this also you guys achieve. Which one? Where's my diagram? Disaster recovery. If one of the computer goes down in any of the data center, doesn't matter, my instance will be anywhere. Okay, so my other instance we will launch. So in this case, we can do a plan. Plan would be, I can launch 2 instances. This instance I can launch in one A data center, this I can launch in 1B. If my this 1B data center goes down, instance goes down, doesn't matter. My load balancer come to know this is out of service. In this case, remaining client requests they keep on sending to 1A data center or A computers, or 1C data center or C computer. So the disaster recovery strategy can be planned in this in this way. So let me recreate this diagram very quickly to add some more point. So now finally, guys, okay, whenever client, so now it's good practice, is always good practice, even though you might have to use only one single instances to run your web app or any applications. Okay, but it is always good practice, okay, always run this instance behind your load balancer. Okay, and guys, when I say load balancer, almost every load balancer has an inbuilt capability called reverse proxy. This is an inbuilt capability of all the load balancer. Even though we have different separate proxy server come in the market, the different point. But if I say load balancer, proxy, reverse proxy concept is always come with them. So it's not separate. Okay. So now onward, I'm going to use the word only load balancer. So even though you have one single instance, always run behind the load balancer. Okay, and always give client IP of your load balancer. For example, this IP is 100. So always give client this IP address. Or I can say always give the IP address of the front end. Okay, why? Due to a lot of reason. If you go why in this way, so client has no visibility about your backend system. So they don't have any connectivity. So management of security and having a lot of powerful extra security we can put in place here. Okay, so these are backend systems. And one of the big reasons why I want to do this setup, by chance, okay, by chance in the future, if you want to scale, so scaling will be so much easy. So if you have this kind of proactive plan, okay, in the future, if you want to add more computers with to handle more traffic, okay, you can launch one more instance very quickly. And as after launch, you can add a new instance to this load balancer. Adding the new instance load balancer is mostly known as register. So we can register this new instance very quickly. Let's say this is the A and this is the B. Very quickly, we can add here. Okay, let's say my backend computer A, what IP would be B to my load balancers. Okay, or maybe if this instance goes down due to some reason, okay, so client itself connect to load balancers, and load balancer guys, we have some kind of rules we can create. I'll show you how. If something is not available, so we can send the client to some other pages that can be managed in load balancers and say, just wait for some minute, we are coming live, or your resources is not available, but you can connect to my customer support. So this can also be possible. If something failed, we can add some extra rules here in the load balancers to send to somewhere else. So it can be handled. Plus, load balancer can also create the logs. So in the future, at least we can see at that point in time how much guys goes down. Means how much guys is not able to connect from this particular client. So some more thing we can do. So having this proper planning, even though you have more one computer running, always run behind the load balancers. This is a good practice to have. And one of the big reason is we can have scale it very quickly, because I don't want to change my IP address every time with the client. I just want to keep it once. Okay, this is one thing. Now, in this plan, you can launch this instance in one A data center, or you can launch this instance in one B AZ. So that is the disaster recovery plan automator. So if this instance fail, okay, your load balancer will automatically connect to this instance behind the scene. It more look like a failover. So if something fail, is not exactly meaning of failover. Rather than I can use the word called high availability. So this is a concept of high availability. So my instances or my application is always available, and this is called high availability. And high availability, guys, you can achieve if you have the load balancer in the front of it. Okay, then only you can achieve this capability. Okay, otherwise lots more plans we can do. Okay, but at least let me start this practical first. One last term I want to tell you here is that if one computer want to connect to other computers, okay, we always connect with the IP address. But after IP address, okay, in this computer we are running multiple program. Which program you want to connect? So every program has a port number. So with the IP address, you have to give the port number also. Otherwise, thing won't work. That's what I told you in my last classes also. Okay. Same thing. If my client is coming to IP 100, we will never connect to the IP, right? To access the data, we always connect the port number. So the front end, you have to give a port number also. This port number is mostly known as front end port number. Okay. Now, because in this IP 100, there is no application running technically internally, right? So you can give any port number, whatever you feel like, maybe 80, 80, 81, whatever you feel like, or maybe 80 also. Okay. But in the backend, this web application, or maybe let's say Apache application, mostly they run on port number 80, or let's say this IP address is IP1. Okay. So this backend URL is IP1 at port number 80 my application is running. Why is it important? Because my load balancer will come to this particular URL. According to load balancer, this URL where actually application is running, this called backend system, this URL is known as endpoint. So they will come to this final endpoint to get this detail. Either you can use the backend IP or URL, or the endpoint is known as. Okay, this is what you have. And in this case, okay, this IP1 is known as endpoint or backend IP address, or port number 80 is the backend port number. IP100 is a front end IP, or IP80 or port number 8080 or 80, whatever you want to give, it will be your choice. Okay, so whatever you give, that will be written by the client. So client will write IP100 and port number 8080 in the URL to connect. Okay, so this is the client for the client. That is known as front end. Okay, so this is the idea. Now, interesting thing here is your instances of EC2 is managed by us. There's the user managed, customer managed. Okay, load balancers is managed by AWS. So AWS has their own service. Okay, and name of service called Elastic Load Balancers. The service name, and this service purely managed by AWS. So AWS is giving taking the 100% ownership and the responsibility of this load balancers. So wherever they're running this load balancer, however the conflict, they're giving you a guarantee, and they're saying if more traffic come up, we increase the benefit of this behind the scene for you. This instance will always up. If one of the data center goes down, they're still running in the other data center, right? So they give you lots of taking a lot of responsibility. You don't have to handle anything. You just have to use it, configure it the way you want to use. Otherwise, the entire responsibility is taken care by AWS. So this is the AWS managed services. That is a good thing. Okay. The only bad thing is because it's been completely configured and created by AWS. So as a technical guys, we don't have to learn much, or we can't see anything what is happening behind the scene. We can only use it as a cloud services. There's a bad thing for the technological learner. But yeah, obviously for the real world perspective, that's what the real world want. They have the service, they want to actually use it, then they should know what is happening behind the scene. But anybody here who is really technical enthusiast who want to learn how we can create this kind of load balancer by ourselves in our own Linux servers. So I think I already announced, guys, and we are launching soon one Red Hat official training is called RS358. Okay, is again one of the part of RSCA track also. Okay, in this training, we have a very detailed topic where we are going to learn how to create our own proxy server or load balancer, how to register, how to do the settings. Everything we're going deep, and we are going to create and configure ourselves. So I'm just giving you extra knowledge. If you want to learn, then you can be part of this program, right? It's one of the topic. Otherwise, like this, we have 100 more topic like this kind of kind of things. But this is one of the topics we have there in this training of Red Hat RS358. We are going to do and configure everything from ourselves in our own Linux operating system. So you can use your way. You can use your way, and you can this is the one topic we have. It is the HF proxies. This is one of the topic through which we can set up this entire thing, right? But yeah, based on AWS Cloud, we don't need to do. They have given you pre-created, so we can directly use it. So I think this is guys some vocabulary I want to give you. Let's start configuring, then we can do some more thing here. So based on this plan, what I explained to you, what I'm going to do right now, I'm going to launch 2 instances, okay, in our 1A data center and 1B data center. Okay, so let me guys write a proper plan. So I'm going to launch 1 instance EC2, okay, with in 1A data center, and 1 more EC2 instance in 1B data center. And according to plan, because my client is not actually going to hit this system, so I'm going to launch these instances in a private subnets. This is also in the private, and this is also in the private. Or I can say I don't want to give a public IP to this guys. Okay, so you can think in this way also. So both will run in the private subnet for extra security. This is one thing I'm going to do. So let me start from here. Okay, and for this, you can use your VPC, whatever you created, or you can use the VPC already created we had. I'm going to use our VPC because the default VPC what we had already, they don't have any private subnet. Every subnet is public there. So I'm going to use our VPC what we created in the last class. Okay, this is I think my LW VPC. In this VPC guys, we had created 2 subnets. Okay, this is the subnet B, and this is subnet A, private. Both the subnet is private. Okay, how I know? Let's check one by one. So this subnet, if you see the route table, and this route table, this subnet number A, private, having a route table, and this route table has no internet connectivity. So this is a different rule. Is I think for VPC endpoint I created in the last class, but technically, okay, this has no. Even though let me edit this, so there is no confusion. So I have to edit I have to go that place. Don't go there. I don't want to waste the time. I want to just want to remove this last line, even though last line doesn't impact anything. But technically, there is no route to internet. Okay, and there's no also net gateway also connected or internet gateway. Nothing is there. It's a pure private. Okay. Similarly, if you go to B private routing table, it is guys again there is no default route to gateway or routers. So they are pure private subnet. Okay, in our views. So let's use this. Even though you don't have to do the pattern this way, you can use if you don't have the setup ready, simple, you can create an instance and put behind the load balancer to test if you want. But I'm trying to make this spectral more sophisticated or more realistic. That's what I'm doing here. So I'm going to launch this instance. Okay, and I'm going to use my AMI because this has already web server configured, so it will save our time. Otherwise, in your case, you can launch your web server or set up by yourself. And this I'm launching behind our VPC in a private A world. There's running in 1A data center. Okay, private A. There's no public IP we don't require. tag. This is my web private in 1A. Okay. Security group, guys, intentionally I am giving right now all traffic. Okay. Why all traffic? I'll show you in the graph. I will do some changes in some time. All traffic, and I'm giving the security group a name. All, not all, web OS private security group. Right. That's what I'm giving right now. So this will be a security group created, launch, and it is in the private key. Maybe I might have to do some login with SSH. So it will launch. Let me launch one more very quickly. I'm launching one more, and right now I'm doing it manually, but those who know automation like Terraform, they can create an automation script for this that will do very quickly. But I'm launching one more in our same VPC, but in a 1B data center, a subnet that is running in 1B. Different data center they're launching, no public IP. And let me give this web OS private 1B. Okay. Security group, guys, I have already created a last, so I'm going to use the same one if they have. So web OS1, same I'm using, and all traffic allowed, review, and launch. So 2 instance launch according to our plan. Okay, one is running in 1B, 1A, one is running in 1B. Both is private IP address. So obviously from outside world, we won't able to connect. But if you want to test this, if working fine or not, okay, fine or not, so only way is with help of basin host. We can use the basin host to check the connectivity. Let me do very quickly. We have one basin host already running. Okay, so what I'm doing, I'm using a connect and connect it to my basin host. Basin host means they have a public connectivity from this, and this guy will have an internal private connectivity. So from this host, I can check the connectivity of these instances. This instance running, guys, already with web server. I use the AMI. So welcome to Linux, who is working fine. And let me check with this also. Outside we can't connect. We don't have public IP. Even though you give the public IP, if you give the public IP, it won't connect because we don't have any internal gateway attached to this subnet. So it is working fine. And due to some reason, guys, okay, because this is a different computer, this is a different computer, I will put behind the load balancer, and to check load balancer is balancing the load. First time my client will connect to this system, second time my client will connect to this system. To check, they will do the load balancing. Okay, I'm changing the data of this. Okay, because both the guys showing you the same data, how you can check the load balancing. In the real world, obviously, you will have to give the same data, but right now for testing, I'm changing the data here, and for changing the data, I'm using SSH with my key. I already copied here in my last classes. If we have here, let me log into my EC2 user. For this, we have a key here, and SSH IP, my key. Okay, my username is same. I'm using this IP address. Let me copy from here. And yes, and I'm changing this data on this file. The data is this one. So I'm changing this data because this instance right now is running in 1B. So I'm changing as a 1B. So echo, okay, I'm changing I am from 1B. Okay, and updating in this file. It won't work because we are logging normal user. We can use sudo. Okay, and a sudo also don't work. I think I give you the way, because sudo will run this as a sudo command, but this not run as a sudo command. But this file we need a permission. So there's one simple basic Linux setup we can do. This command we can run So any this kind of symbol come up and you want to apply the sudo, this is the way we can do it. It's a pure Linux commands. Opens up, it work fine, and this file has been updated. Sorry, it's not updated. Sorry, I add and wanted single quote here. Why? There's no requirement of this. Sorry, is permission denied. 1 minute. Why is permission denied? Sudo, I think single quote, double quote inside double quote doesn't work mostly in most of the languages. This might be the reason. Yeah, double quote doesn't work. So I put single quote in this. So updated. So this system has 1B and other system will tell you welcome to the next one. So let me log out from here. Again, from a base computer, I'm doing the curl again. This system is giving a different message and this other system is giving a different message to us. The other computer is this one. I'm going to change the content so I can see the load balancing happening fine or not. So if load balancing happening fine, so first when I first client connect, they will see this message. Other client connect, they will see this message. So it means load balancer is happening fine. Okay, so now we have this system running with a different content, or mostly in the real world. Obviously, we have the same website we should have. Now it's time to have our load balancers. Okay, so we are going to put the load balancer here. This is known as elastic load balancers. So how we configure this? So based on this concept, we explain to you setting up the elastic load balancer one take much time. Okay, so one like this. So how we can do this? So ELB is a sub-service of EC2. So in this EC2 page, only if you see the left side, if you go down, there we have a concept called load balancers. Okay, and the target groups. Okay, right now if you see the target groups, nothing is there. Okay, what target group, and I'm going to explain you. And if you talk about load balancers, nothing is there. Okay, now if you want to create a load balancer now in the Mumbai region, just click here. And now guys, there's 3 different kind of load balancers we have. Okay, one is ALB, NLB, and GLB or GWLB, I can say. So what are the use case of this? Wait for just tomorrow class. I will first explain you more use cases, and depending on use cases of load balancer, we will pick one. But the use case that I explain you right now, a typical use case of load balancer or reverse proxy, right? This use case can be solved with the 4th one, or I can say the older one. This is called classical load balancer, CLB. CLB is the older one load balancer, and then they're soon, and soon they are going to expiring it in August 15 this year only, this load balancer. But till before this, we can use this one for doing something. Okay, so right now our practical, what I'm going to show you can be shown by this load balancer as a previous one. But after having this practical completed, then I will explain you some more use cases that can't be solved by this. Then we have to move these guys. But the core concept I explained you is same in all. Okay, so let me start with the CLB, classic load balancer. Okay, so I am going to create a new load balancers. Click create. Okay, and here guys, they're asking you the load balancer name. Let's say my web load balancers. And this load balancer you want to run in in which VPC? So idea very simple. Okay, if your load balancer, whatever IP would be, right, want to connect to this IP1, if they're not running in the same VPC, how they connect? Because this IP1 is a private IP. Okay, and private IP can be only connected with any other computer in the same VPC. So that is one of the reasons your load balancer would run inside your VPC only. So I'm just using our VPC name. This is the VPC name. Okay, so this is what we have set here. Next point is, do you want to create your load balancer internal? So I will tell you some more use case why you want to create your load balancer internal. Internal means you don't want to give public IP to the load balancer. And there's a lot of interesting use case for this. But right now, in our case, I want to give my load balancer public IP, so my client can connect to this public IP. Okay, that is a reason I'm not selecting this, but I will tell you in my upcoming, maybe tomorrow class, what is the use of this. Okay, now here they're talking about load balancer protocol. Means when the client come to the load balancer, which protocol they're going to use, mostly HTTP, and which port number they're going to connect. So which protocol they want to use. So HTTP is also support, but let me use HTTP right now. Which port number they want to connect, let's say 88 according to our example. Okay, and when this load balancer connect to your backend systems instances, which port number they will connect and which protocol they use. Okay, so again they use HTTP protocol and the port number of the instance. This port number you can use anything, but whatever you use, that will you have to give it to client. But this port number you can't use anything. Okay, based upon your application. For example, right now my application is running on port number 80. You can't give a TT here; it won't work. So whatever application work on which port number, that what you have to give here, instance port or backend port. Okay. Again, this concept is known as when it means my client will connect on this load balancer, and load balancer will listen to client at this IP and port number or this protocol. This is not a listeners. So it is set the listener on the load balancer. So listener configuration we have. And if you have more application you have, maybe sometimes it is possible one system have multiple application running or port running or features running. So more and more listener we can connect with different ports numbers. Okay, that's what we can add more. Now this setup is done. Now we have to select the subnets. Because right now I would like to connect my load balancer to different instances. Now you have to pick your instances running in 1A or 1B or both or 1. So in this VPC, you have to select your subnet. Okay, and even though they also suggest to have the provide high availability for your load balancers, different AZs you have to select, means 2 at least subnet you have to select. Then only you will have set up actual setup of high availability. And these are the different subnets we have. So which subnet you want to select? We know our instance is running in 1A and 1B private. So this is the private. Oh, this is a private I am going to select. So I'm going to add this. Okay, and this is also I'm going to add. Okay, so in this VPC, this 2 subnet I am going to add. Okay, so it means your internet facing ELB. Why is internet facing? Because right now my ELB, this is called Elastic Load Balancer. The ELB is one service name. Inside ELB, there's 4 different load balancers we have, classic or other guys. We are using CLB here. So let me write here. ELB is a name of your service, and inside this there's 4 different types. Today we are discussing CLB, classic, older one. Okay, that's what they're talking about. And here they say is internet facing, internet, because we are attaching, not selecting as an internal, means public facing, anybody. It means they will give a public IP to this. Okay, and they also guys give warning, there is no internet gateway attached to subnet, we just select it. Okay, it means they're talking about, okay, you are using internet facing ELB. Okay, but there is no internet gateway attached to the subnet. It means what a challenge you will face. I'll show you in a minute what challenge you face. Okay, for this. Even though, okay, let me go for next. I will explain what challenge you face. Okay. Next, they ask you security group. Now here, this is security group for your load balancers. Means load balancer also have guys security group. So this is the client you have from the internet. And before the load balancer, you have a 1 firewalls security group. Okay, security group. So obviously, guys, because of our load balancer, whatever IP would be, my load balancer working on the front end port number 80. So I want any client from anywhere can access this port. Okay, so this is security group we have to add. So I'm going to create a new security group. This is a load balancer security group for port number 80. Okay, and I say this because this is a kind of TCP protocol. I would like to allow this port number from anywhere in the world. So this is a security group for the ELB load balancers. Okay, click next. This is giving a warning. You are running load balancer publicly. So you have to use some HTTPS. That's what we'll discuss in the future classes. Okay, for extra security means encryption. But right now I'm not doing this. So let me go for next. Next is health checking. Okay, health checking means what I explained you already. Okay, whenever you when you launch your instances, behind the scene, your instance will keep on checking the health. Okay, so it is like this. Let's say A is your load balancer and B is your backend instances. So load balancers keep on checking your health. Okay, so that any client come up, load balancer will send that request or process request to you. Only if your health is okay, means you have a connectivity. And for checking the connectivity, load balancers keep on pinging you. And as ping is a protocol you guys might know. If you do normal ping as a ping command, sorry, if you do a normal ping as a ping command, okay, this ping command work on protocol called ICMP. And most of the cases, guys, in the server, ICMP is blocked. Okay, so if you try to ping B, the server side is running, but it look like it's blocked. So that is the reason the good way to ping is, okay, rather than ping on the ICMP protocol, ping directly on the server. Because server is working on the protocol HTTP, okay, and server has a web server running on 80 port. And server has a web page. Most of the web page is index.html, and because this is your server, you know which page number, page name you have. So I can ask my A, try to do this, try to server this protocol, this port number, and this page. If you can access this page, it means they're pingable. This is called HTTP ping or TCP ping. So this is what we normally do. So pinging via HTTP or port number 80, and we're accessing this page. Or whatever page you have in the server, you can access this. Or this page, if it's bigger, you can make this one a smaller page just for health checking. The only motto of this page is, okay, if this page is accessible or downloadable, it means your server is running and there's no issue of connectivity or downtime or any kind of load or any kind of page or any kind of security issues. Okay, so whatever page you have, in my case, by chance, I have this page with us. Let me refresh this page again. In our case, this page is there. Whatever the IP would be. So in our case, you guys know pattern, what is the IP? 1 minute, let me open a new page because you might require EC2. So in our case, this is the page by default we have. So check this IP address. By default, our page name is, if you don't write the page, by default page name is also this, then this is what the page we created. So either you can ping this IP address or this page number or ping on the slash, both are same. You can use slash also there. Both the things are right. So you can write this or you can write slash. Both things are right. Now let me write this one to make it more clear what we have here ping. Okay. Now, interval between the pings. I told you guys ping is a continuous process. Maybe after some time they're down. So A will keep on pinging to B. How frequent? It depends. All right. So how, let's say if you're pinging right now is ping, but after 2 seconds is down. But if your interval of pinging is 30 seconds, means after 28 milliseconds, you come to know that down. It means load balancer have no clarity till 28 seconds they are down, and still they're sending request to B again and again to client, and B is not responding. So client is not facing for getting the proper reply. What I mean by this, okay, if let's say A is your load balancer and B is your instance behind the scene, this is load balancer, and if your interval of pinging is 30 seconds, okay, it means A ping to B, let's say right now let's say 0 second, and B say I'm okay, I'm live. Okay, after 30 seconds, they will again ping. This is called interval here, this interval. Okay, but there's a possibility maybe after 2 or 3 seconds, let's say after 2 seconds after, your instance B goes down. Means till 2 seconds to 30 seconds, around 28 seconds, your load balancers have no idea that it goes down, because they will do next ping after 30 seconds. It means till 20, from 2 to 30 seconds, your B is down, but A feel they are live. So any client come to A, they keep on sending request to B, and B is not replying. So it's not a good service or you experience for the client. They will see this is disconnected. When next time, because client is connected, client normally re-send the request. When next time A might send to other guys, there's a by default nature because they do load balancing. But initial they won't connect. There's a different point. Okay, so in this case, you can decrease the time, maybe let's say 5 seconds. But again, lesser time is not good, because if you give the lesser time, there's a 5 seconds, 0 after 0, 5 seconds, 10 seconds, 15 seconds. So they keep on pinging, so it will unwanted waste, impacting the extra load on the backend server. So depend, guys, you have to choose this parameter depend upon your requirement. If you think your application is very critical, okay, maybe 2 second downtime is not you think is right, then you can decrease the interval. Okay, but if you think your application is very reliable, you can increase the time, but you got to save the unwanted extra hit from the load balancers for checking the load or checking the health. Okay, that's one thing. But one more small thing here is what load balancers do. Let's say my time interval is 5, so 0 till 0 5 1 5 seconds they hit, then 10 seconds they hit, then 15 seconds they check the health. Okay, we go right 5 seconds here. Okay, but let's say at this point in time, till here, let's say server is okay, but at this point in time, server is down. Means A hit to B, B is down. Okay, but in the first call, B is down or is called unhealthy. They don't declare B as unhealthy. Okay, they still keep B with them. This is called registry. They keep register B with them. And there's a possibility they think there might be some network errors, there might be some system may be rebooting that point in time, that they might be down. So again, they try after 5 seconds. Okay, again if they're down, again try after 5 seconds. Okay, after 2 or 3 tries, this is called unhealthy try 2 by default here. After 2 try, this is the first try they did, their second try they did. Okay, after this, they will declare B is down. Then they make the B as a out of the service. Then they derestrict this, something like this. Now in the future, they won't send the request. We can do it again, connect, there's a different point, but now onwards, they won't start sending the ping to the B. They declare as this out of service. So before you make it unhealthy, how many requests will you send? That's what we can check here. Depending on your requirement. If you think in the company, mostly you do a lot of patching in the server, you have to restart your backend servers. Restarting might take maybe 2 minutes sometime. Okay, and you don't want that point in time server not as a out of service, then you can increase the time and the intervals also. And same thing with healthy. Okay, the first time when any new computer connect to the load balancers. Server ping, 0 second, again 5 second they ping, again 5 second they ping, again 5 second they ping. Before they restore this guy, okay, before they restore this guy and start sending the client uh, traffic, they check multiple times the health, and after checking multiple times the health, then they mark this guy as a healthy, and then only they send the traffic that is called healthy time. So 10 means 10 means total 10 times. So every 5 seconds they send the request, total 10 requests they send. After 50 seconds, they mark this guy as a healthy. Let me change to 4 right now. I want to make this instance become very healthy very quickly. Okay, and response timeout means if your instance is sending request to B, okay, as a health check on page called index.html, okay, B will reply. B might reply in 1 second because page may be heavy, page is busy, page have something that will load from the database. We don't know. Okay, so if B is responding and processing this page and replying in 1 second, 2 seconds, okay. But if this page is taking more than 5 seconds, there's a timeout. Okay, there's a timeout. So maximum time the system can wait is 5 seconds. We can increase or decrease also. Okay, that's called response time. So I think guys, every keyword I explain logically because I've seen a lot of places having the right knowledge of this keyword is not proper. It look like very confusing, but I believe by having this example, you have a clarity about every particular component, and it is not a standard. Not a standard means to fix any number. It's all depend upon what kind of application you're running behind the scene. So multiple example use case I will explain to you. So this parameter we can change according to your requirement. So then add the instances. Now guys, in our this particular this particular Mumbai, all the instances that we are running here, it will be visible. Okay, so these are the different instances we are running right now. They're showing you all the instances, even though they're showing you public also. Public also. Okay, now what is important, what I'm trying to tell you here is, okay, so one more interesting point, guys, I want to tell you is there's something confusing. You are running your instances 1A and 1B in private. Load balancer is also like a one instance running behind the scene managed by AWS managed. But you want your load balancer has a public IP. And public IP, guys, of the load balancer is only available if your load balancer is running in the public subnet. Your public subnet is the one who can give the public accessibility. Your public instance, sorry, public subnet. Public subnet is the one who normally give public IP, or normally public IP actually means public subnet has an internet gateway connectivity. It means if you don't put your load balancer in public subnet, your load balancer won't have a public internet connectivity because we have the internet gateway only public subnet. And if you have internet connectivity or internet gateway, then only guys client can come. Maybe you can say right in this way. Then only client can come to internet gateway through which they can go inside your load balancer, and through the load balancer they will go to your respective instances. Okay. So point is, if you want a load balancer to be kind of outside world, if this is the case, then you have to put your load balancer in the public subnet. And that was the guys warning coming up. Okay, behind the scene, right after load balancer configured, you want to put which instances. That is a different point. These instances may be coming public or private, doesn't matter. So they will list you all the public and private. So the public instance they give you, private instance they give you. In the Mumbai region, you can select anybody. Okay, but if you don't put your load balancer in the public, thing won't work. That was the guy's warning. That's what the screen I want to show you here. But that was a warning guys coming initially. So let me go to my initial page. Okay, this is the warning coming here. Okay, and this page, guys, is the page for load balancer. Okay, guys, load balancer is also a kind of instance. Okay, and if your use case was this one, let me show you one more time the use case. If your use case was if 1A is a data center and 1B is a data center. Okay, and if you feel this data center might goes down, then client from the internet can connect this. This is called disaster recovery, means you want high availability actually. In this kind of use case, your plan will be something like this, because your load balancer is like instances only behind the scene. So you have what you have to plan. You have to plan in this way, even though let me give a little bit better plan. Okay, so guys, this was again, this diagram will become from a VPC class only. This is what we have created in the VPC, and that is the reason why I created this diagram in the VPC classes. Okay, so how you have to do it? Okay, it will be something like this. You have one subnet. You have one subnet running here. One more subnet we have. One more subnet we have, and one more subnet we have. Okay, and let's say this subnet is running in 1A data center, running 1A. This is running 1B. This is running 1B. Welcome back. And this subnet is a public. This is a private. This subnet is public. This is private. Okay. In our case right now, my instances is running here. EC2 in private. And one more EC2 running in private. But one is running 1A, one is running 1B. It means 1A goes down, 1B instances is still running. But load balancer also you have to plan in this way, because you want load balancer to be public accessible. So you have to put your load balancer in public subnet. And actually you have to create two load balancers, because your plan is disaster recovery or high availability. Okay. In this case, because load balancer is public subnet, it means we have an internet gateway that is already connected to your public, and through which your client can come in. Okay, client can come in. Okay, so client either connect to this guy, either connect to this guy. It means we have one more load balancer on the top of this. And this one more load balancer, guys, is being created by AWS for you. You don't have to worry about it. And this load balancer, guys, they created with the help of DNS. So DNS is also one service that can also be used as load balancer also. How? So when I talk the topic called Route 53 in my upcoming classes, I'll explain you there how. Okay. So initially what happened? Your client, we will give a IP address. Instead of IP address, we give a domain name by DNS. So let's say my domain name will be linuxworld.com or www.linuxworld.com. So when the client hit to this name always go to DNS. Okay, and DNS behind the scene give the IP address. And in this case, DNS will give the IP address either of this load balancer or this load balancer. Let's say this load balancer IP will be 100 and 200. Okay, so client will have the IP address of, let's say 100. So client will connect to IP 100. Next client come up. Okay, next client come up. Then they always go to DNS. Why? Because we are using name. Name will always first convert into IP by DNS only. More about DNS, guys, we'll see in the upcoming classes. And DNS will give the IP address. At this time, DNS will give IP 200. Because DNS can be useful or it can be used as a load balancer only. Okay. So this time my client will connect to IP 200. By same time, guys, DNS can also work as a failover also. Failover means DNS has capability So any client come to DNS and say, this is the www.element.com. DNS will give the IP. Before they give the IP, they check the health of your load balancers. Okay, and maybe at this point in time, the entire 1A data center goes down. So this entire setup goes down. Your load balancer also goes down, and instance also goes down because they're running in the A1A. In this case, your DNS, okay, the DNS come to know your 1A goes down because means your load balancer goes down of IP 100. In this case, when the client come up, they will only give the IP address of 200. So they will give the IP address of 200 and they connect to 200, and load balancer will connect to remaining internal backend systems, whatever they connected. Okay, they connect this. Technically, every load balancer connect all the instances. This load balancer connected to this also, and this also. Both the guys are connected. Okay, but this is the remaining part of load balancer. Now load balancer know this instance goes down because they check the health, so they will be connected to this one. Okay, this is the typical setup everywhere. If you go to google.com, facebook.com, DNS is always your first load balancer. Okay, so when you type www.google.com, every time you will get the different IP address. See, even though, see here, if I type www.google.com, my DNS will give up this IP address. Next time it might give it different. Okay, in this case, they're giving IP6, both the sides, both the cases. But mostly you will see in most of the cases, they give a different IP address. Even though if you ping, you might get different. Even though in my case, IP6 is coming, but they give you different IP address all the times. Okay, and most of the time I can say. So point here is, this is the setup we have. But why DNS? Okay, I have one more detailed discussion in the upcoming class or Route 53, but this is the setup we have. So finally, the setup would be the client for internet is always connect to DNS. And guys, if you have any doubt in this case, what happens if the DNS goes down? The DNS never goes down. Whenever DNS goes down, it means your entire internet of the world goes down. So DNS is like internet. It will be split everywhere in the world. So DNS never goes down. You can think this. Okay, and behind the DNS, we have two load balancers running. Load balancer number A or B. Okay, and behind the load balancer, we are running multiple instances. Instance 1, instance 2, instance 3, something like this. So this load balancer connected to this one also, this one also, this one also, and this load balancer connected to this also, this also, and this also. Okay, so in this case, if this instance goes down, so my client can come maybe to this load balancer, this load balancer will send to this guy. Okay, but maybe by chance, if your load balancer goes down, so client with the help of DNS will go to this load balancer, and this load balancer connect to this instance or with this instance. So everywhere we have the high availability, whatever the way you architect. So this is one of the architect design, right, of the load balancers, right? And that easy region, it is good practice to have a high availability on the load balancer because load balancer launch per AGs. Okay, and if your plan is if AG goes down, I don't want my service goes down, then in this case you have to launch your load balancer in multiple AGs if you want to have high availabilities for this. Okay, but your load balancer to be launched in public subnet if you want your load balancer will have a public connectivity. Okay, that is the reason, guys, I'm changing here. This is the page for load balancer, the first page, and here I'm selecting in what subnet my load balancer to be deployed. So I'm putting in the public only, public and public. Okay, guys, this is very important page. Otherwise, you guys confused with this line and the last page of this configuration. So this is what I explained to you, the use. And now in this case, now there's no warning. We have, because I want my load balancer to be public. This line is not selected, public. So for this, you have to put the load balancer in the public subnet that has interrogative connected. Plus, I want a high availability setup. If one of the AG goes down, second AG will have the load balancer running. So that is when I select two subnets. So in both the subnet, my load balancer will run behind the scene. Okay. Security could be same concept. This is a port number for the load balancer. This is a different warning because right now we're using HTTP, not HTTPS. Health check is same. Okay. Now, two instances I want to run. One is my this instance and this instance. One is running in 1A, one is running in 1B. This has no relation with your load balancer where they're running. Okay. Running in my case, if the load balancer running here, they can connect to this guy or they can connect to this guy. Right. Now, there's two concepts called cross-zone load balancing and connection draining. We will discuss at this point in upcoming class. Means tomorrow. Okay, I'm just giving. I'm going for by default settings, but what are the use of this? Cross-zone and connection draining. We'll discuss. Add tag. I don't want. In the setting, you want to change. You can change. I don't want to change. Okay. So here's one small warning. Checkout time must be less than the interval. Okay. So let me review and resolve. This is what they're talking about. They say this time should be less than that. Obviously, logically. Okay. If you're pinging every 5 seconds, and some application will take more than 4 seconds, so they're same, right? So it will let me lesser, always logically. Okay. So first ping you're doing right now 0, then you're doing 5 seconds, then the first response will come within 4 seconds. Otherwise, there will be confusion, right? So that's what they're talking about. So it will be less always. That's all. So guys, your load balancer has created successfully is a purely managed by AWS. What we have done, we just ask them and use them. Right now, we see the instances, they're out of service. Why? Because we have set the health time and say we will do after every 5 second check, and we do 4 checks for health checking. And after 4 check means around after 20 seconds, if your instance is pingable, there's no firewalls issue. Okay, pingable and service running, then we'll make this service both the instances 1 and 2 running 1A, 1B status to be healthy. So let me refresh one more time. Now in service. So they check these instances and they say they have connectivity. They try 4 try. Okay, because this is what we have checked set the health checks. 4 try the check every 5 seconds around, and they make this guy as a instance in service. Okay. And right now what this line says, okay, we are running with the load balancer, one load balancer running in 1A that is connected to one instance count, and second load balancer is 1A that has I can say it's not like this. This is what in 1A data center, one instance running, and 1B data center, one instance running. It's not a load balancer. They are just talking about that we have one instance running in one data center. It's about instances. This is what they're talking about. You find instances. Okay. This page. This is the listener. If anybody want to connect, you can connect on this port they're talking about. Right. And finally, if you see the describe, okay, because this is the internet facing load balancer, and the way I explained to you, okay, because you are using internet facing and because you're using two load balancer, because you have two different public subnet you use for disaster recovery. So these load balancer guys is been further load balanced by DNS, and that is the reason guys they don't give any public IP. Public IP you can't use for load balancings. Okay, in the DNS. So DNS will do only load balancing with the public host name and the domain name. So client will have the host name or the domain name of your load balancers. That's what they give you here. Your DNS. You don't get any public IP. You can get this public DNS. And what status is in this VPC, 2 is running and 2 are up. No, is nothing is down. Is internal facing. Okay, this with the DILs and some more settings we have. We'll see security group, other things also. Okay, now let's see everything working fine or not. So let me copy this DNS name. Right now, if I hit my DNS name, it won't work. Why? Because the port number of my load balancer, what we planned already is 88. So let me show you where it is. The port number we planned is 488. Okay. So what we'll do, it's not working, obviously. You have to connect to port number 88. And let's see output come up. Right, working fantastic. Understand one thing, guys. If you see this particular page, okay, so I am a client from my system. Hit to this IP address or to the port number. This is a front end IP address and port number. But behind this thing, guys, they hold my request, go back, get the data, and send to me here. They are not redirecting me. If they redirect it, then I will connect to my final server, to the server IP address. I'm still there in this page, and behind this thing, they get the data and throw to me. So for client, it looks like it's coming from load balancer, but internally coming from a different website. So that is the reason I'm using word reverse proxy. Okay. And second thing is your instances is running in the private world, right? Even though no public IP address, even though I can get my data. How I already show you the concept. We reach here and they will connect and get the data. And this load balancer has a public IP. That's the reason I can get the data. And because they're also using reverse proxy, so it doesn't matter they have public or private IP address, so we can get from private IP also. Okay, and if I refresh this page, last time output of this one, when I refresh this page, let me refresh this page, you can see there's it. That means my load balance is also happening fine. Okay, so first time they connect here, second they connect here, then they connect here, they connect here. So you are getting a proper load balancer. Sometimes you refresh, you won't see it. It change. If you don't change, they're changing, because that is one of the reason is you normally browser get caches. So that is not the issue from the load balancer. Sometimes your local browser get a caches, so they won't show you. Okay, so if you don't change, they're not changing. Okay, that is the reason of the caches, right? One last thing, guys, for today. One thing I haven't said properly here is your instances right now, even though they're running private, it means nobody can outside can connect. That's a good thing. But instances has running with a security group. Okay, and this security group, guys, is public accessible. Everybody can come in. Okay, it means my instances that is running right now, okay, has a security group, and security group says, okay, anybody can connect all traffic. Okay, it's not good rule. The good rule is, because instances right now is running with web server that is running on a port number 80, okay, or on HTTP protocol. So you only allow HTTP on 80 port. But this part you know, but the main point is we have to allow from where? Our load balancers. But do you know the load balancer IP address? Because there's two IP addresses, guys, of load balancer, are public, and you guys know public IP is never belong to instance, it's belong to internet gateway. But do you know the IP address or the private IP address of load balancer, your private facing IP of the load balancer? Do you know? Let me check. Okay, So in the load balancers page, okay, if you see here, do you know the private IP of load balancer? I don't think so. They will post here. There is no private IP they show you because it is running behind the scene. They should have, but they are running behind the scene. Okay. So in this case, which IPs are allowed? Because there's no good reason to allow all. It's not good reason to allow all the network events. By chance, we know the network name because load balancer is running in one network or subnet. We can allow all network, but it's not good practice. Okay, the good security is if you want only load balancer will connect, so only allow load balancer IP address. Okay, this is one point. And second point, by chance we don't know the IP address of load balancer. Second point, okay, there's a possibility my public IP or load balancer is same, it won't change, but a private IP might keep on changing. Okay, but in this context, there's one more interesting feature of security group. Okay, the feature is if A is a computer, B is a computer, and this is the security group of B. And let's say this is a security group of A. Okay. If you want, A can come in B to do something, let's say access port number 80, and you don't know the IP address of A or my private IP of A, you don't know. And maybe private IPs keep on changing. This may be one of the case, keep on changing. Okay. In this case, let's say this is dynamic IP address. In this case, how can you create the rule in security group? So you want to create a rule that anyone who want to do HTTP on port number 80 only from this instance can come. But I don't know IP address or IP address might be changing. How can we do? For this, there is one more concept of security group, guys, and that is the only concept we left in my initial classes. So I told you guys, I told you in my security classes, security group, there's one concept left. That is the concept I'm explaining you right now. Okay, the way we can do is in this case, okay, we can take the help of security groups. The one unique identity of security of A is this security group. A has their own personal security group. It's fixed, it's not going to change. So what can we say? We'll tell my B that anybody from the source system, the IP will change or we don't know IP address, but they have their own security group, let's say security group A. So we can create a rule, anybody from belongs to security group A, come to me B and try to access this, allow this. So what I'm trying to do here is my firewall, so not firewall, my load balancer is attached to this security group. This security group is called LB security group 80. Okay. I don't know the IP address of my load balancer. I don't know. Maybe IP also might change in the future. Let's say A is my load balancer here. Okay. So what I can do, I can go to my computers and say the source IP I don't know. So I want to use custom, and custom would be, I would like to use the security groups names. Here there's a lot of name come up here. So instead of IP address and the port IP range, you can give a security group name also. In this case, the group name is called LBSZ. LBSZ, this one. Okay. So any computer where the security group has been attached, in this case, the security group has been attached to my load balancer. So load balancer is a source. If load balancer try to connect, so you may not spare. So let's forget this. So if any computer from the system belongs to the security group come to access this port number, we are allowed. That is the right meaning of this line. Okay, so this is one very common thing we in the security group will do. Mostly the case where the IP addresses keep on changing. Okay, so if source IPs keep on changing, then we can create this kind of rule. I don't know why this warning is coming up. Let me do one more time. So this is the LB security group we had. You may not specify a reference group ID of existing L4. Let me save it. It should 1 minute. You may not specify a reference group ID. I don't know why this message come up. It should work. Let me change this. So, but this is the guy's idea. It should work. Why this warning come up? Let me edit this. Okay. So what I'm doing, all traffic instead of all, let me use HTTP. This custom anywhere. We don't require LB security group. I just tried. I don't know. Maybe some setting I've missed some in some VPC. I don't think so. All right, but it should work. Right now, this console, just keep in mind. Just check it, or I will again try in next class. It will already be very, very late. Okay, so at least till now, I allow all. But this is, guys, one concept I want to tell you. By chance, this is a good example, but I don't know, warning. We can troubleshoot, but we've been late right now, so I just skipping this point. Okay, but this can be done to make this thing more powerful in the terms of security. Okay, so that's all, guys. This is the classic load balancer. Okay, we have now this load balancer has a lot of limitations, not more, lot of advanced settings we can do. Even there's some more concept of stickiness and some more things we will discuss in my tomorrow class. Then I will move to some advanced load balancer for ALB and NLB, other topics, right? So that's all, guys, in today's class. Any query if you have till now, you guys can ask me. Okay, any queries in this ALB? A person that is not, it is not like there's the pretty fixed number to handle multiple requests. It's vary from server to server. So every server has their own configurations. In the configuration, you can check which fork they're using, and that will tell you the connection limits. Even though if you're the part of my 355 training, this is one web server topic we have. I show you there how to go and check how can we do that. So, Sushil, can you ask me again what actually doubt you have? Proxy, reverse proxy, I will explain to you. Proxy is not the part of the discussion, so it's a little bit different concept. So I'm not going for that particular part. Yes, Krishna, Kumar, tomorrow we will discuss our NLB. Okay, NLB and ALB we will discuss tomorrow. When the DC where the LB is placed goes down because of their start do, they fail auto next stage. Yes, Krishna command will happen automatically because on the top of load balancers now we have one more load balancer called DNS. So if the entire 1A goes down where my load balancer is running, automatically DNS will send a next request to load balancer B in my 1B data center. So it will happen automatically. We don't have to do anything with it. Okay. So yes, right now for load balancer here they are using round robin algorithm Santos. Okay, this particular load balancer, what are you seeing here? They are using the algorithm called round robin, not the random. That is the reason when I refreshing the page, you can see first request goes to 1A EC2, second go to 1B EC2. Why? Because round robin is the one who will send one by one. Okay, it's not random. So that's all, guys. See you next class tomorrow with some more detail about load balancers. Bye. Take care. See you. Good day.